The circuit above consists of an ideal battery, two resistors, an inductor, and a switch. The switch is initially open. At time t is equal to 0, the switch is closed. In this situation, after a long time that the switch is closed, the switch is now open. We need to calculate the current in the resistor R2 immediately after the switch is open. So the situation is that after a very long time that this switch here is closed, we suddenly open it, and then we would want to know the current through resistor 2 immediately after the switch is open. So as a matter of fact, current would be flowing in this path here due to the presence of the inductor. So the inductor with its back EMF will cause the current to flow through resistor 2. But we also have to remember that when this switch is closed, after a very long time, there will be no current flowing through R2, and that is because the inductor is going to short circuit it. So when we close the circuit, current will be flowing through this path right here. And when we open, and when the switch is now open, the current will be flowing through this path. So now we need to remember that an inductor almost provides like an electrical inertia in a circuit. It does not want any changes in the current in the circuit, and therefore it creates its back EMF to prevent any changes in the current in the circuit. As a matter of fact, what would happen is that the current through R2 would actually be equal to the current that was initially flowing through R1, and this is just equal to the voltage across R1, which would be equal to 12 volts divided by the resistance of R1, which is 20 ohms, and this is equal to 0.6 amperes. Now let us verify this with a simulation. Now currently there's no current flowing through the circuit because the switch is open. Now let's close it, and as we close it, there's current flowing through R1, which is equivalent to 60 amperes. And since the inductor is short circuiting R2, there's no current that will flow through this branch. Now we have reached a steady state. The question that we had in the sample problem wants us to know the current that would flow through R2 once the immediately when the switch is open. So let's try that out. I'm just gonna pause this, and then I will open it now. There you go. So there will be no current through R1 because the circuit is now open, because the switch is open. So current will just be flowing through the resistor and our inductor. And as what you could see, the current that flows through resistor 2 is actually 0.6 amperes, which is equal to what was flowing earlier in R1. And if you notice, the voltage, the back EMF generated by the inductor is consistent with Ohm's law. So that if this is our resistor, which is 40 ohms, and the current that flows through resistor is 0.6 amperes, then the voltage across the inductor should be about 24 volts. Now let's see what happens if we click on play. So immediately after the switch is open, there will be a current that flows through R2, which is equivalent to what was initially flowing through R1.